Algebra I, 11.9a, solving equations containing radicals. A radical equation contains a variable in a radicand. And to solve these equations, we first convert them to equations without radicals. We do this by squaring both sides of the equation. So the principle of squaring, if an equation a equals b is true, then a squared equals b squared is true. Now pay attention because we can't do this in reverse, okay? If a equals b is true, then a squared equals b squared is true. So a has to equal b. Now we need to watch out for extraneous solutions. Those are solutions that don't fit the original equation. So we can say a equals b being true is going to make this true, but just because this is true does not mean this is true. We can't flip it around and make them both true. Watch. If a squared equals b squared, does a always equal b? No. Just because these being true makes this true doesn't mean this being true makes this true. We can't turn it around. Okay? Watch. If a equals 2 and b equals a negative 2, well, a squared is going to equal a 4 and b squared is going to equal a 4. Negative 2 times negative 2 is positive 4. But a is 2 and b is negative 2. So see how if we flipped it around it doesn't work? It doesn't always work. That could be an extraneous solution. We talked about extraneous solutions before. So we could do it going in this order. We can't flip it around and make it go in the other order, okay? All right? I hope I explained that well. I know that's confusing. You can go from a equals b to this, but you can't go from this to a equals b because two negatives can make a positive, all right? So we need to solve and check. So here's our problem. We've got the square root of 2x minus 4 equals 7. So the first thing we're going to do is isolate this radical. So we're going to use additive inverses, and we're going to take this 4 out of here. So we're going to add 4 to each side. That's going to create a 0 pair and get rid of that, isn't it? So now we've got the square root of 2x is equal to 11. And what we do is, the principle of squaring, we square both sides. So we square the square root of 2x and we square 11. And we get the square root of 2x times the square root of 2x. Well, what happens is that removes the radical sign. By squaring it with a square root symbol, it just removes the radical symbol. See that? So just remember, if you've got a square root sign and then it's being squared, it completely removes the radical symbol, okay? So now we've got 2x is equal to, 11 times 11 is 121. We've got 2x equals 121. We can isolate x by dividing both sides by the coefficient of x. We learned that a long time ago. So if we divide both sides by 2, this turns into identity property, our friend the invisible 1. We get x is equal to 121 over 2. 121 divided by 2. So now to check it, we don't need to do anything to this. We can keep it just like this. We don't need to simplify it more. We just plug in 121 over 2 for x in the equation. So here's the original equation. We just put, because this is multiplied to each other, right? So that means we're going to multiply the 2 by 121 over 2. And if it's over a 1, then this 2 cancels out this 2 as a 1, doesn't it? So we end up with just 121 over 1, or the square root of 121. Well, we know that's 11 times 11. That equals 121. So that means we have 11 minus 4. And 11 minus 4 is 7. 7 equals 7. So it's true. See? Just plugged it in, and if it's true, we're okay. Now look at this. We've got radical symbols on both sides of the equal sign. So the first thing we're going to do is we are going to square both sides of the equal sign to get rid of these radical symbols. So by squaring them, we get rid of the radical sign, and now we just have x plus 1 equals 2x minus 5. This means the square root of x plus 1 times the square root of x plus 1. See? And this means the square root of 2x minus 5 times the square root of 2x minus 5. And by squaring these, we just pull off that radical sign on each side. Think of it this way. If we had the square root of 16 and then we squared it, that means we've got the square root of 16 times the square root of 16, right? Well, the square root of 16 is a 4, and the square root of that 16 is a 4. So that means we have 4 times 4, which is 16, see? So by squaring it like that, basically all we have to do is just pull the radical sign off, because it's going to equal what was under the radical sign, the radicand, okay? So now we just have x plus 1 equals 2x minus 5. And we can use additive inverses to isolate x to one side of the equal sign. So we can get rid of this minus 5 by adding 5 to both sides. That's going to create a zero pair here, right? And now we've only got 2x on this side, but we've got x plus 6 on this side. So we still need to isolate the x. So now we're going to take away the x from this side and take away an x from that side. And that created a zero pair here, right? That's gone. Now we just have 6 here. And there's an invisible 1 here, isn't there? So 2x minus 1x is just an x. See? So 6 equals x. And we can check it out by putting a 6 in the place of the x. Square root of x plus 1 would be the square root of 6 plus 1. So that's the square root of 7. And this would be 2 times 6 minus 5. And that would be 12 minus 5 would be the square root of 7 is the square root of 7. It's true. See? Just make sure you check it, because if you made a mistake, that's when you'll catch it, all right? And if it's true, you know you did it right. So here's another one like the first one. We've got the square root of x minus 2 minus 5 equals 3. So the first thing we got to do is isolate the radical. When you see it like this, the first thing you do is isolate the radical. When you see radical signs on both sides of the equal sign, the first thing you do is square both sides. See? See the difference? So we're going to isolate the radical. So we're going to add 5 to each side, create a zero pair here, right? Get rid of it. And now we've got the square root of x minus 2 equals 8. Square both sides of the equal sign, and we'll get rid of that radical symbol, and we get x minus 2 equals 64. We can get rid of this 2, can't we? By adding 2 to both sides. Now we have x equals 66. See? And now we've isolated the x. Now to check it, all we have to do is plug in 66 for x in our original equation, and we get square root of 66 minus 2, which is square root of 64, which is 8. 8 minus 5 is a 3. Yep, it's 3. So it worked. Okay? So our next video, 11.9b, we're going to discuss when there's radicals in the solution, and these are going to be word problems, okay? We did radicals in the equations. What happens when there's a radical in the solution? And if you want to click on the description of this video and go back and watch the one about finding the legs or hypotenuse using the Pythagorean theorem, or finding the legs, the distance between 2 points with the distance formula, that'll be in here. And then there was some Pythagorean theorem word problems that we just did in the previous video. So here's previous and helpful videos, okay? All right. We're going to go to the next video, and I'll see you there. Keep trying. I'm proud of you for getting through this. Bye.